Welcome to Algebra, Writing Systems of Equations, Part 2. In this coin problem, there are 15 nickels and dimes worth $1.20 in all, and we want to know how many of each coin there are. We use x for nickels and y for dimes, expressing the first equation to represent the total number of coins, being x plus y equals 15. And then the second equation showing the total worth of the coins, with 0.05x plus 0.10y equals 1.20. Let's use the substitution process for this one by solving the first equation for y, and then substituting the right side of y, negative x plus 15, into the second equation. Working through this substitution finds the value of x to be 6 nickels. Substituting that value back into the other equation finds the value of y to be 9 dimes. The graph of these two equations confirms this solution. In this example, tickets are on sale for a school play, $4.50 for an adult ticket and $3 for a student. 300 tickets are sold for a total revenue collected of $1,087.50. The question is asking how many student tickets were sold. This is another perfect situation for using a system of equations to solve. First, we represent the adults with the variable x and the students with y. We express in sentence form the number of tickets sold, 300 as the total of adults and students, the equation being x plus y equals 300. And then we express the money collected, $1,087.50, as the sum of the cost of each ticket times the two variables x and y, for the equation 4.5x plus 3y equals 1,087.5. All three solution strategies will work for solving this system: graphing, substitution, and elimination. Let's look at each one, starting with graphing. To graph an equation in Desmos, the star testing version, both equations must be in slope-intercept form, y equals mx plus b. We convert the first equation by subtracting x from both sides, resulting in the equation y equals negative x plus 300. In the second equation, the x term is subtracted, and then both sides are divided by the value 3, leaving y isolated on the left with the expression negative 4.5x plus 1,087.5 all over 3 on the right side. Both equations are graphed in Desmos, and we see the resulting point, 125, 175, as the solution, representing 125 adults and 175 students. Using substitution requires only one equation converted to isolate a variable. Let's solve for x in the first equation, and then substitute into the other equation. The first equation solved for x is equal to negative y plus 300, which is then substituted for x in the other equation. We work through the equation solving process using distribution, combining the y terms, subtracting 1350 from both sides, and finally dividing by negative 1.5 to find 175 as the value for y. Replacing this value for y in the other equation shows x to be 125, the same solution we found by graphing. Using elimination, we see that the y terms easily relate, and only need to multiply the first equation by negative 3 to enable the y terms to drop out when the equations are combined, solving for x to get 125. Substituting this value back into the first equation finds the value y to be 175, again, the same solution as before. In a recent basketball game against the Chicago Bulls, the Los Angeles Lakers scored 80 points with a mixture of 2- and 3-point shots from the floor, 37 shots in all, not counting free throw points. How many 2-point and 3-point shots did the Lakers make? We use x and y to represent the 2- and 3-point shots, with the first equation being x plus y equals 37, and the second equation the sum of the value of the shots, 2x plus 3y equals 80. We'll use graphing to solve this problem. First, converting both equations to slope-intercept form, solving each for y, and then graphing them in Desmos to see the two lines intersecting at the point 31, 6, representing 31 2-point shots and 6 3-point shots.